Hello and welcome to my YouTube channel Technocrats. In this video, we will look at RD78G, that is a motion module used with RCPU. So let's get started. And we'll be using MR-J5 and MR-J8 for this project. So click on New. It's RCPU R04. Change the setting to use label that I prefer and click OK. Okay, now let's just do one thing. We can do module configuration. So here we will be using main base rack as our 35, and we can have the power supply 7P, and CPU is already here. Now we will drag and drop the motion module, that is motion module from here. So this is RD78G4. So this is for the sealing I field TSN, and if 8 axis also, and 16 and 32 axis available, and 64 and 120 and 250 is also available. For the SSC net, we have 4, 8, 16 only. So we'll be using 4 axis. Okay, once this is done, so configuration is complete. Double click here, click yes, and again click yes. Okay, now so make sure that you install the motion control setting function patch in with your GX Works3. So this is available on Mitsubishi website, so you can download it from there. Now go to the navigation part. First, let's do the network configuration of the module. So we'll go to the network configuration setting. Here we will add the servo access which we require, like MR-J5-G, and let's use MR-J8G. So these both work on sizzling TSN network. Now we have here you can set the IP address of both of these. So I'm taking 3.1, 3.2 as default, and if you wish to use the servo parameters, you can double click here in the parameter automatic setting and click yes. Okay, so this window will open and it will show you the parameters that are for the MR-J5-G servo drive. So you have this network parameter. Let's say the IP address will be set via rotary switch, or you can use parameter option, where then you can set the IP from here itself. Okay, so yes, yes, again this is for the JET servo. That's two. Yes, okay. Now close the window and click yes. Now moving to the communication speed part. So I'm using 1 Gbps. So if you're using some hub which supports 100 Mbps, you can use 100 Mbps, or if you're using some slip ring that supports only the 100 Mbps setting, then you can use the 100 Mbps setting for the communication. Once this is done, click apply. The data is saved. Now moving towards the module extended parameters. So this is the module extended parameters. So this is the software I told you earlier about. This is a motion control setting function that you need to install with the GX Works3, and it is available on Mitsubishi website. Now here on the axis, right click and click add new data. Then you have the device data servo name, data name. So let's say I use access1 as my name. Let's say 01 and click on three dots, and here you can select the access number 1, which one it will be. So let's say we use MR-J5-G as our first servo. Click OK. Now again click right click here, add new, access 2, and let's select MR-J80G as our second servo. Now before we proceed on to the Apple signal configurations, here let's make a global variable. Before that, let's make a structure. Right click here, add new structure, and say as data. Click OK. Here the input and output bits which we require to run a servo, because in this case what we are going to do is we will develop the program itself in the motion module, this software motion control setting function. Here we will make the program, and this program will be written to the motion module itself, and we will share some bits and words with the PLC using labels. So from there you can set the command and it will work. The two-way communication will be there from the motion and CPU. So let's use like power on. Then we have error reset. So these are the inputs for the motion module. Power on, error reset. Then we have jog forward, jog reverse. Also select the bit here, data type. Then we will have the power on is there, error reset is there. Then jog forward, reverse, jog speed. Then we have positioning, start. All these are bits. No, sorry, this is not bit. This is our double precision float. Number you can say, or you can say posting address, and positioning speed, same as the double precision. Also, what else we have? Access stop, and we can have don't write access stop, let's say stop only. This is a bit. Then we have force stop input. Then we have upper limit, lower limit. All these are words. Now in the public label, let's enable them. Okay. Once this is done, let's go to the, let's compile it first. Label incorrect, stop. Okay. Rebuild, recompile. Now let's move to the initial part, that is our access setting. here we have this upper limit signal, so we can assign a signal here which we have already made, but we haven't used it in global yet. So axis 1, that is okay. Axis 2, the data type itself will be a structure that we have used to make as data, click here as data. Okay, now enable this once again. Also we have this function like attribute, so we are writing it to the motion from the PC, from the PLC. So that is why we are using this directional write command. Again, rebuild it once more. Now what we have to do, we have to put this target here, the upper signal. Here we'll select the source, that will be our source data type. Here we can write axis 1 dot our upper limit signal. Same goes with the axis number 2, that is axis 1 dot upper limit. Okay, this is same where we can do it for the lower also. Let's just skip that and just move to the another part, that is our drive unit configuration. So here, as in the previous simple motion module, you have already seen that we can assign the mechanical structure from here, like how it is running. So let's say it's in degree, and we have might be using gearbox of 1:2. Click here, calculate, and click OK. Simple. Same for this. Here, let's assume that data is okay, and calculate, click OK. Yes. Once this is done, this is the force stop signal. You can configure it as we configure the upper signal. That is our stop, access stop signal. Same for the access 2. Access dot, sorry, access 2. Click OK. Let's check once more for the heroes. Access 2. Okay, now moving. Something done. Oh, this force stop signal. Let's change this to force stop. Click OK. I'm moving down. This is our stop now. You can configure it. I'm skipping this and just so this is done. Now what we'll do, we will just make a small program to enable the servo and use the jog instruction to move it forward and reverse using the jog command. So in motion itself, you have this option for the program. In the normal execution, click add, let's say main, click OK. So on right side we have element, click on POU list, go down, and you have these instructions to execute, like power instruction is here. So I will drag and drop. I will use axis 1 restore power on and click OK. In the reference, we will use axis dot access reference. In the enable, I can use access, or you can use true. And in the servo on command, we can use access one dot power on. So this will come from the PLC. I will show you how to configure that in the PLC, how to use this label in the PLC. And for the status ready and all, I'm skipping those as of now. You can use actually, but I'm skipping for now. Then we will use the reset command also, because error reset is required. Access one error reset. Click OK. Then we will use access one dot access reference. We have to use access one dot error reset. Then we have this all the I'm skipping these as of now. You can use labels, more labels, to get the status and the done bit of error reset or any of the instruction. Now let's move to the jog instruction. Jog access one jog. Click OK. Same access reference from here. Access one dot jog forward. Copy paste. Jog reverse. Then the velocity, jog velocity, jog speed. Okay, we haven't used, I think, jog acceleration, so I'm using jog speed only for the acceleration. Also the acceleration. Then we have several other options also, like servo is busy using this instruction, or that done is there, active is there, command is aborted, error. I'm escaping these as of now. So after this, you can use compile instruction and rebuild the program. Okay, there is some error, I think, here. We have to remove this too. Rebuild. Now let's move the labels that we have used here into the PLC program. So you can do is you can go here, convert, and there is an option like reflect public labels. Click here, click yes, click OK. Now minimize this. Now in the PLC program, you have to write this synchronization flag from the motion module, and you need to use Y0 as output to make the motion card ready. So X0 is your ready command. After you implement Y0, then you will receive X0 as a command for motion card ready. Okay, so how to use label? Let's say I'm just adding labels to the watch window. So the watch labels will be like RD78 underscore 000 dot access 1 dot. So what we have used, first we have power on. So power on, click yes. Then we have RD access 1. What else we have? The error reset command is there. Then what we have, jog forward is there. Let's copy this for the jog reverse, and yes, jog reverse is there. Then we have jog speed. I think we have all these, only these we have used so far. So let's compile the project. Okay, done. Now we have also used the force stop inputs and upper limit. Okay, now we can simulate this. First, let's save the project. Click yes. Click OK. Now let's simulate the whole project. Click add location, center G, click start. Okay, once done, minimize this. Go to debug, simulator, connect simulation, and click connect. Now transfer the program. Click here, execute. It will take a while to be write in the motion module. Once this is done, click OK, close the window. Then we can have this stop, reset, and run. Okay, now let's check. So to check the status, we have the option here, like in the online section we have motion monitor. Click here. This is our motion monitor. All the access are disabled. Make services and access to are disabled at now at present. So if I turn this power on signal to true, you can see the access status has turned from disabled to standstill. Okay, now I haven't yet enabled these two for the access 1 and access 2. So let's try to jog it first. It will show an alarm, then we will check the reset instruction. So in the jog, it's running. Okay, and what about this? See, if I'm turning this on, it is bypassed. Now if I move to jog forward, it will show an error stop. Okay, so error we have here, error code is here. Now let's disable the force stop input and try to reset the access. Error reset by on. See, now it's going to the standstill position. So you can also see the whole here also, like if I simulate, if I monitor these instructions, you can also see the okay, why it's not showing right now. Let's increase the speed and try to forward jog. So it's jogging approximately. The actual position is going fast, and the set velocity is 1000, and actual velocity is coming up to be 1000 point something and around that. Now, when I turn it off, it will deaccelerate to 0. So this is the jog part of the servo. Now, check the reverse also. We check reverse. Yes, it's moving the reverse action. and the access state is showing continuous motion. So this is the jog. Now moving towards the positioning. So for positioning, first let's check what settings are required and what we have done earlier. So for the absolute system, I'm not using any setting here. So you can use, if you want to use the absolute positioning, you can use the absolute positioning type. Like for the J5, it's batteryless absolute, so you can use the absolute system. Now we have the torque is there, positive torque, negative torque, and settings like home required for the motion. Here we have home required or not, homing required. So if you want to execute the homing, you can execute the home. If not, you can skip that. So for the homing part, let's go here. Is home OPR access one home. Click OK. The reference is access one. The same reference will be used throughout the program for the access number one. So we haven't made any label yet for this. So what we can do is either you use the SDT again here, like home command something, or just for now I'm using the global variable here, like access one home command. This is my bool type bit, and I will just write it to the motion. Same can be done for access number two. Access one home command. That's it. Position, that is K0. Now for the motion, you have the help here. So there is my MC home command. Target position, where let's say I want to use 0, so my default value is 0. Okay, so maybe switch options and all don't have to use. I'm just skipping these. You can always use the done bit. You can use. I will just add another label for this. So going to the global label, access one home done bit. So despite of using one-to-one structure bits, you can always try to use the SDT, that is structured data type, sorry, for the access commands. Because once you set it for access one to access one, all the commands, so same you can will be copied for the access two also. Okay, now it's I think done. Then we'll go to here. Access one home done. Command is here. That's it. Label is and fixed parameters. Click apply. So required is here. And, okay. Let's do one thing. We also can use the positioning command also, like move relative command we can use. So access one relative access one dot reference access one dot positioning start. distance. So axis 1 dot positioning address, axis 1 dot positioning speed. Now for the acceleration I'm using the speed only. Jerk other modes in not required as of now. You must use it when you are using the actual program. Okay, now convert it. As we have added some labels to the global that are to be transferred to the PLC. So for that we need to do one thing. Okay, so let's compile the program. Now click on reflect public labels, click yes, click OK. Minimize this window and we are good to go. We will just write the program once more. Of the program using also the motion module settings. Execute and able to write this also. Converted. Okay. You need to compile this also because there are some changes in the global level. Now let's transfer the program. Click execute. Yes. There is another option also available where you can use the function blocks in the ladder PLC to control the servo, and you don't have to write anything on the motion module. So there are options available to do that also. It is taking some time to process. Click yes and close the window. Now let's reset the PLC once. Stop, set, click OK and run. So now let's again monitor all the use here. So this is disabled. Okay. Okay, so now it's in standstill position. Let's do one thing. Let's say forward command. Okay. The reverse command is also working. Now we have additional values like home is there. So access one home command here. Access home done is also here. So when I click on the home command, see the position set position is turned to be 0. So that this is just that the homing is done. Now we also have some homing related bits available with our motion module. So I will show you here in the watch window of the motion module itself. Right, access one real access dot md dot homing. See this homing complete, request, homing required, homing status. All are available here. This is homing complete, access one dot homing. Sorry, md dot request required. Okay. Now let's monitor these. Click on start. Now let's go to the positioning part. Axis 1, sorry, RD dot axis 1 dot positioning start. It is our rule RD77 dot axis 1 dot positioning address. That is our value where to go RD77 dot positioning axis 1 dot positioning value also there. So axis 1 dot positioning speed. Now, let's say we write here some value and okay, same goes for the speed like 5,000. Now if I trigger this, it is moving at a speed of 5,000 degree per second, and the command position is this. So it is moving towards target. Now let's see if the target can be changed, like when I re-execute the command. So we have this command in position signal, so it can tell you that the positioning is complete. Also, what we can do is we can check here in the motion itself about the like axis 1 axis for the mean, axis 1 relative motion, not like done here, and busy is also here. So all these commands can also be monitored here as well, and you can also transfer these values to the PLC. So in this video I have taught you about the axis power on, jog, axis home, and relative positioning. So like this, we have several more other options also. Like if you want to use the torque control mode, you can use the torque control mode. If you want to use the speed control mode, you can go for the move velocity type of function block. And we have multiple options like cam in, gear in, and all these are available here. So that's all in this video. If you like my video, please like, share, and subscribe. Thank you.